Hello everyone, I'm Dr. Fawzul. I'm giving some series of lectures on the course Probability and Statistics. So in the previous lecture, we have discussed the probability of equally likely outcomes, and then we discussed a couple of examples. In today's lecture, we'll be discussing on conditional probability. So a conditional probability is a measure of the likelihood of an event occurring given that another event has already happened. It helps us understand how the occurrence of one event affect the probability of another. So you are finding a probability of some event given that some another event has already occurred, right? It is not just probability of an event, some condition is imposed on it. So some probability of some event provided some another event has already occurred. So we'll be discussing the probability of this kind of event. So let S be a sample space. Let S be a sample space of a random experiment containing n equally likely outcomes. Right? So the S has n number of outcomes. All of them are equally likely. And let A and B are two events related to this experiment. Now, out of the n outcomes, total outcomes, suppose m number of outcomes are favorable to the event A. So if m number of outcomes are favorable to the event A and S has small n number of total number of outcomes, therefore what should be the probability of A? The probability of A is equal to m divided by small m. Okay, now out of this m event, so we have m outcomes are favorable to A, right? So out of these m events, this m outcomes, suppose k outcomes are also favorable to the event B. So note that these k number of outcomes are the events of A as well. Correct? So therefore, we are considering the if event B is happening provided A has already happened. Okay. Now, think of that. What is the A intersection B? See, K number of outcomes are also favorable to the event B, but they have already there in the event A. So A intersection B is basically the event. It has like how many number of elements? It is K number of elements. Correct? Now after that it is easy to understand. So then what we can say, probability of A is number of outcomes favorable to A divided by total number of outcomes. We have already discussed it is m by n. Probability of A intersection B, we already discussed here that A intersection B has k number of elements because the outcomes of B are also the outcomes of A. So total number of, therefore probability of A intersection B is equal to total number of outcome favorable to both A and B divided by total number of outcome, which is k by n. Right? And therefore we will discuss now the conditional probability of the event B given that A has already occurred. So it is the probability that an outcome favorable to A is also favorable to B. So previously we have discussed that P of A is equal to small m divided by n and P of A intersection B is equal to k divided by n. Now what is the conditional probability? It is the event that probability of the event B where given that A has already occurred. So it is P of B by A. We can denote it by this way. And it is the number of probable cases of the event B. What was that? It was K because we already said in the beginning somewhere that k number of outcomes are favorable to the event B. So I have k number, and this k number we have taken from where? That the m number of outcomes of A. So P of B by A is equal to k by m, because the outcomes of B are the outcomes of A basically. So we are taking the number of favorable cases for A. So k by m. Now we have got a relation. We can certainly write P of B by A into P of A, and it is equal to k by m into m by n, and that value is basically k by n. But this k by n is also the probability of A intersection B. So I can also write down it as P of A intersection B. And therefore I got a formula P of B by A, the conditional probability of B provided A has already occurred, is equal to P of A intersection B divided by P of A. So now onwards we can think this is a formula for that, right? So whatever I said, it is, this calculation is already done very formally. So P of B by A equal to P of A intersection B divided by P of A. And therefore we can define the conditional probability, that the conditional probability of an event B, given that another event A has occurred and assuming that P of A is greater than 0. See, I am saying that probability of an event B is where another event A has occurred, that event should be positive probability. Na? If that event has 0 probability, then there is no meaning of discussing this thing. So probability of A should be greater than 0. And in this case, it is defined as denoted by P of B by A and defined by P of A intersection B divided by P of A. Right? So this is called the conditional probability. Similarly, if I ask that what is the conditional probability of the event A given that another event B has occurred, so you can denote it by P of A by B and is equal to P of A intersection B divided by P of B. I hope it is clear. Very easy thing. So this is the explanation behind the conditional probability. Now let us solve a few examples. Look at this problem carefully. A coin is flipped twice, assuming that all 4 points in the sample space is equal to this, that we already know. If I flipped a coin twice, I'll get the sample space in this way. H, 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 T, T, H and T, T. That means both the times head is appearing. Next is first time head is appearing, second time tail, then first time tail, second time head, or both of them are tail. Now, what is the conditional probability that both flips lands on head, given that the first flip lands on head? Now, you denote that, suppose A be the event that both lands on head. So, both the coin heads. Suppose B is the event that the first flip is head, and C be the event such that at least one flip lands on head. Now, what you have to do, try to think what is the question, that what is the conditional probability that both flip land on head. So we have to find the probability of this event, provided given that the first flip lands on head. That means the B has already occurred. So we have to get the probability of this event where B has already occurred. What is that? So this is the probability of A by B. Now you think that this formula from the previous discussion we got, this is P of A intersection B divided by P of B. Now you think that what is the event A? What are the outcomes favorable to A? So the A is equal to, which set? Both are heads. That means it has only one outcome, HH. What is B? B is the first flip is head. That means it has two outcome, HH and HT. And C is at least one head. So C is equal to at least one head. So it has three outcome, HH, HT and TH. Clear? Now what is A intersection B? So we have A intersection B is equal to which set? So A and intersection B, it is H comma H. So what is the probability of A by B? So I can get final answer as probability of A by B is number of favorable cases in the event A intersection B, which is 1, divided by total number of cases, number sample space, it is 1 by 4, divided by probability of B is what? So it is 2 divided by, because B has 2 number of outcome, divided by total number of. So it is, final answer is 1 by 2. So therefore, the probability that both the flips land on head, where the first flip lands on head. So it is already happened. So it is P of A by B, and the answer is 1 by 2 in this case. Right? Now what you have to do for the next one? At least one flip land on head. So same way we can do. So at least one flip land on head. We can just get the formula. I'm just taking this as somewhere. I'm just rubbing this part. So I'll be doing the second part. So the part B, at least one flip. So what is the probability that both flip land on heads, given that at least one flip land on earth? So it is the probability of A by C. And the formula is P of A intersection C divided by P of C. Now probability of A intersection is C, no P, sorry. Now what is A intersection C? It is again only one event, A, H, H. So A intersection C is, I should write it here, A intersection C is equal to, again that it has only one event, outcome H, H. So probability of that is 1 by 4 divided by probability of C is what? It is 3 by 4, because C contain that 3 number of outcomes. Total number of outcome is 4. So therefore, probability of C is equal to 3 divided by 4. So if I simplify, I'll be getting this value is equal to 1 by 3. I hope it is clear. So we got both the conditional probability. So whatever I discuss, the very formally it is written. You can easily see the answer for this, that we have already discussed. The P of A by B, we got it 1 by 2, and P of A by C equal to this formula, and finally we got P of A by C equal to 1 by 3. I hope it is clear. Let me move to the next question. Okay, look at this problem carefully. Suppose that of all individuals buying a certain digital camera, now 60% include an optional memory card in their purchase, 40% include an extra battery, and 30% include both a card and a battery. Then you have to find the probability that a randomly selected buyer purchased an optional memory card, given that they purchased an extra battery. So again, it's a conditional probability. We have to find the probability of the event that a buyer purchased an optional memory card, where they have already bought an extra battery, right? So it's a conditional probability. So let us name all the events. Let A be the event such that a buyer purchased an optional memory card. Maybe I'm writing that memory card. For a short, I'm writing. So a buyer, this A be the event that a buyer purchased an optional memory card. And B be the event we are denoting it such that the buyer purchased an extra battery. Then what is given? What is the probability of A? It is given that 60% include an optional battery memory card. So it is 60 by 100 is equal to 0.6. Similarly, P of B is equal to what? 40% include that. So 0.4. And it is also given that 30% include both a card and a battery. So it is P intersection B. P of A intersection B is equal to what? 0.3. Now what is the question? Find the probability that a randomly selected buyer purchased an optional memory card given that they purchased an extra battery. So therefore we have to find that probability of A where they already bought a battery. So probability of A by B. Now we know the formula. It is P of A intersection B divided by P of B. And all the formulas is given. Substitute this value 0.4. So it is 3 by 4. Next example, the probability that a randomly selected buyer purchased an extra battery given that they purchased an optional memory card. So that means probability of B by A. So probability of the event A, conditional probability of the event B, where A has already occurred. It is again P of A intersection B divided by P of A. Just substitute the value. It is 0.3 divided by 0.6 and it is 1 by 2. This way we can easily solve this answer, solve this problem. So formally, everything is written in very formal way. You can see this answer. Yes, that's what we have discussed. That P of A by B equal to this, P of B by A equal to that. Let me move to the next example, which is a very interesting and little big example. But if you can able to solve, like if you understand this, conditional probability concept will be very much clear to you. What is the question? A new magazine published 3 columns entitled Art, which stands for A, Books, which means B, and Cinema, which stands for C. The reading habit of a randomly selected reader with respect to these columns are as follows. So everything is given. What is the probability of the event A? What is the probability of the event B? What is the probability of the event C? A intersection B, probability of the event A intersection B, probability of the event, everything is given. Probability of the event A, B, C, everything is given. You have to find that compute P of A by B, which is the conditional probability that the reader regularly reads A given that they read books. So what is that? You can easily solve this problem. P of A by B. Maybe I will do it here itself. You know the formula, conditional probability of A given B has already occurred. So P of A intersection B divided by P of B. Everything you have already. Just put the value 0.08 divided by P of B is 0.23. So it is 8 by 23. First one I have done. The easy one. Now you have to do for the next one. It says that compute the probability of A by B union C. Okay, let us do. So you have to get P of A by B union C. How to do that? So we know the formula. So it is P of A intersection B union C divided by P of B union C. This is the conditional probability formula. Now how to do? Yes. So let us find the probability of the above event. So P of A intersection B union C, it is equal to P of A intersection B union A intersection C. We know principle of inclusion exclusion principle. So it is equal to P of A intersection B plus P of A intersection C minus P of A intersection B intersection A intersection C. Note that all of them are the intersection only, while A is repeating. Now you just substitute the value. A intersection B is what? 0.08. P of A intersection is C is 0.09. Minus this value will give you A intersection B intersection C, right? So A intersection B intersection C is 0.05. It is also given. And therefore, if you simplify, you will get the value is 0.1. And similarly, we can find the P of B union C. We know the formula again. P of B plus P of C minus P of B intersection C. Just substitute the value again. Because P of B, C and intersection C, every value is given. If I substitute, we will get 0.47. And therefore, if I substitute this value, and this value in the formula, I will be getting this is as equal to 0.12 divided by 0.47. So it is 12 by 47. Now if we have another one, we have to find this one. Probability of A by A union B union C. So conditional probability of A given that A union B union C has already occurred. Again, we can directly put the formula to solve this one. So this was number 1. This was number 2. Now we are going to do number 3, which is P of A by A union B union C. We know the formula. It is P of A intersection A union B union C divided by P of A union B union C. Conditional probability. Now let us find this value. So now look at that. P of A intersection A union B union C. Can you think of this value? Is it not that A is a subset of this set? And if I just do the intersection, I'll be getting that is A only, no? So probability of A, because A is subset of this set. Now what is probability of A? It is also already given. Probability of A is 0.14. So this value is 0.14. Right? Now probability of A union B union C. Again, we know the formula for principle of inclusion exclusion. So take all of them individually. P of A plus P of B plus P of C. We have already discussed in some of our lecture. Minus 2 to we have to take, and alternatively plus or minus. So it is P of A intersection B minus P of A intersection C minus P of B intersection C. Then alternatively plus or minus. So this time it will be plus. They are all three intersections. So A intersection B intersection C. Now all these values are already given. All the values are already given. Substitute the values. You'll be getting it is 0.49. And therefore substitute these values. This is 0.14 and this value here in this thing, we can get the answer is equal to 0.14 divided by 0.49. It is 14 by 49. We can divide by 7, so it is 2 by 7. We can get this answer. I have one more problem remaining. I'm going to show you. So this formally every solution is given. You can just take a snap of it. We have already discussed this part. That number question 1, question number 2, and the third part. All these things are formally given the answer. And then you may, for your homework, you can just do this one also. Whose answer is also given. So you just put the formula, do your, like, solve them. You should be able to get this as the answer. Okay, I have the last example, which is very interesting. An urn contains 10 white, 5 yellow, and 10 black marble. A marble is chosen at random from the urn, and it is noted that it is not one of the black marble. Then what is the probability that it is yellow? Very, very interesting one. So first you denote the event by some alphabet. Suppose W be the event that if you randomly select, you will get the white. Similarly, let Y be the event that you will get yellow marble, and B is the event such that you got it is a black marble. Now you also think that how many total number of outcomes are there in the urn, so total number of balls. So the sample space is basically 10 plus 5 plus 10 is equal to 25 number of balls you have, right? Also you find that what is the here it asks that a marble is chosen at random from the urn, and it is noted that it is not one of the black marble. So it is noted that it is not one of the black marble. That means it is the event that B complement. So if it is black, then it is the event B. So it is not black means it is B complement. Okay. So what is the probability that it is yellow? Therefore, we have to get the probability that it is yellow given that it is not a black one. So therefore, we have to get the conditional probability of Y given that it is not black. So Y by B complement. Now Y by B complement, we can now we know the formula. It is conditional probability formula P of Y intersection B complement divided by B probability of B complement. Now what do you mean by Y intersection B complement? We had B that you will be getting a black marble. B complement means it should be either white or yellow. B complement is equal to basically white and yellow, right? Now Y intersection B complement is basically white union yellow. Na? Now Y intersection B complement is what then? This is the subset of this set. So this is basically again Y only, because B complement is W union Y. So Y intersection B complement is Y again. Therefore, what is the probability of Y intersection B complement? It is the, so number of element in Y, cardinality of the set Y, it is 5 divided by total number is 25. And what is probability of B complement? Probability of B complement is number of cases for Y and W. So it is 10 plus 5 divided by total number of outcomes, number of outcomes in the sample space. So it is 15 by 25. Now you substitute these two values in this solution, we can get, therefore, P of y by b complement is equal to 5 by 25 divided by 15 by 25. And therefore it is 5 by 15 and is equal to 1. We got the solution as 1 by 3. Very interesting problem. I hope you understand this, right? So the formally also the solution is given. You can take the snap. So here it is little like I have explained it little more elaborately. You can go through this way, or it is very shortly it is given. I hope you enjoyed the lectures. So all the definitions, examples are mostly from these references. So if you like the video, please give your feedback. If the videos are helpful, please write that as well. Okay, thank you very much. We'll meet in the next video.